Welcome to the next generation real-time online automated mobility counting and traffic analytics webinar organized by AUS Türkiye as part of its webinar series. Let me introduce myself first. I'm Yiğit KİPMAN. I will be moderating this webinar. I am co-founder and CEO of Turkish micromobility company HOP, which is providing micromobility services in overall Eastern Europe, in total 21 cities and 3 countries. With the help of emerging connectivity technologies, IoT devices, and efficient battery technologies, shared micromobility is also a major shareholder for intelligent transport systems. And we are also members of AUS Turkey. Today, we have 3 distinguished speakers from different time zones around the world, both from Turkey and United States. Throughout the webinar, we will get their contribution and deep knowledge in the field of ITS, mobility counting, and traffic analytics. So let me introduce our speakers firstly. Our first speaker will be Mr. Hicham CHATILA. He is the managing partner in strategy and partnerships of the company Neovision. He's the principal engineer in transport engineering with 37 years of hands-on ITS experience in North America, Europe, and MENA region. He's an expert at national and international level ITS conferences, public and private areas, including US government, and he's the vice president for ITS Washington. Our second guest will be Mr. SAADANI, Mohamed El SAADANI. He's the founder and CEO of the Neovision company. He's a principal engineer in transportation engineering with 40 years of hands-on experience in transportation planning and traffic engineering, both in United States and MENA region. He is inventor of several technologies that they use in Neovision today, and he is also an advisor to New York City Department of Transportation. And our third guest is Dr. Mohamad TALAS. He is Director of Intelligent Transport System and System Engineering in New York City Department of Transportation. He has a PhD in Transportation and Planning Engineering from NYU. Dr. TALAS has over 30 years in traffic engineering and operation experience in New York City Department of Transportation. He is currently supervising the planning and development of ITS projects in New York City and has received various awards from ITS America, ITS New York, and IRF, including New York City Connected Vehicles, New York City Midtown in Motion, Smart Lights, and Advanced Traffic Controller projects. So before we start, I would like to note that we are live on YouTube, so all the attendees can ask questions during the webinar, and I will be asking those questions to our speakers at the end of our session. So first, let's start with Mr. CHATILA. Mr. CHATILA, would you like to introduce yourself one more time briefly and then keep on with the presentation?
Yes, thank you. This is Hicham CHATILA. Good morning. It's a honor and a privilege to present to you this morning. As mentioned, I've been practicing for quite a bit of time in the realm of ITS in North America, in the Middle East and North Africa, specifically in the Dubai region and in Doha. In addition also to, some work in Europe. My main focus is on ITS and emerging mobility and safety solutions. So with that, can I share my screen?
Erol Bey, can you let the speakers share the screens as you are the host? Erol Bey or Hayrettin, are you here? Can you let us share the screens, please?
1 minute, please. Okay.
Okay, is everybody able to see my screen?
Yes, we can see it, Mr. CHATILA.
Okay, so I'm going to go ahead and get started. So this afternoon, we're going to talk about a framework or an architecture, kind of from a planning perspective, what it takes, to build robust ITS infrastructure systems. I'm going to skip the slide. I already talked about myself, and so the presentation is as follows. Effectively, we're going to focus on what we call here the USA National ITS Architecture, which is a national framework for the entire US of A around basically the planning framework for planning and implementing ITS solutions. I'll cover a little bit about the system engineering concept, which is tied effectively to the USA architecture as well, and then we'll open it for questions and answers. A system architecture or a framework really provides a framework to ensure that ITS technologies or other technologies can work together smoothly, seamlessly, and efficiently. It's not just about the technical aspects of the ITS or the framework, but also the institutional side, meaning the government agencies or even the private sector, the roles and responsibilities as well. So why do you have why this is important, or why should you consider a national ITS framework or architecture? It provides basically a vision, a direction for ITS in general in the country or the region or the city, which so you can do a framework not just at the national level, meaning the entire country, but you can do it at a state level or government level or city level as well. It creates standards, so there are some consistency across, and it obviously develops the need for why certain ITS solutions are needed for that. Again, I'm going to quickly go over this because we only have 10 minutes this morning. So the importance, the reason it's important, you define and establish overall program goals or project goals if you want, and the outcomes. What functions are we going to perform? So if you're implementing an ITS system, what functions are you trying to perform? What standards are you using? Are you using local standards, national, international standards? And what are the outcomes and the goals of the, as we discussed, as the projects? We discussed this already. Determine, who and how, they're going to operate and maintain these systems once they are designed and constructed. How information is shared and exchanged, both internally, let's say within the government agency, or with external users like, the driving public, whether they are, riding the bus or the train, walking, bicycling, or driving their cars. Lastly, and more importantly, is encouraging the use of open standards, so they can, different systems from different vendors can basically interoperate and can communicate with each other. as I mentioned earlier, the focus here today is on the USA National ITS framework. And on the slide here, you see this is a screen capture of the website. And so the link below is the link to this website. And this is I encourage everyone who is interested in the subject on ITS planning, standards, system engineering to basically visit this site, and it provides a very good introduction and a lot of details about this. So there is a link to visit this USA National ITS architecture or framework. So quickly, I'm going to go over this framework. So the US basically National ITS framework looks at this from 4 different views or perspectives. The first one is what we call the enterprise view. So and that means which agencies or government entities or private sector, who is doing what services are they providing. The next view discusses the functions to be implemented, and again, these are extensive. There are many pages and documents and figures if you visit the site I just mentioned and showed. Lastly, the physical, how things are interconnected, where are they located, what they do, that kind of stuff. Lastly is the communication protocols. If we're talking, let's say 2 traffic management centers, for example, in different regions, they want to communicate. How are they going to communicate the different standards? Or even if with emerging technologies like V2X technologies, vehicle to everything, what standards are we using? So these are the 4 particular views that the US National ITS architecture covers. And this is an expanded view of what I just showed earlier in the previous slide. And it provides a little bit more information, about, again, the enterprise, the roles, the relationships, the needs, the functional view, the functions that are to be, what are those requirements, the data, how the data is going to flow, the processes, and then the physical, the communication. Ultimately, all this leads to a set of adopted, what we call ITS service packages. Whether these service packages are, urban traffic management, parking management, fare collection, different types of ITS service packages. And obviously, cybersecurity is very important as part of the work we do in the ITS realm. I talked about service packages. So this is just a glimpse of some of the service packages that the USA National Architecture covers. This is just a small sample. There is a lot more. And as I mentioned, I encourage you to visit the website and to look at all the service packages and all the elements and sub-elements associated with all those ITS service packages. So if we consider, for example, an ITS infrastructure for urban centers, let's say, Istanbul or Ankara or New York or Seattle or different, most of the ITS infrastructure is going to fall within these elements that are shown here on the screen, whether it's, traffic control and management, freeway management, public transport, multimodal traveler information, emergency, so it's going to cover most of these or part of this. Lastly, I want to kind of talk a little bit about it. So as part of the USA National ITS framework, there was a recognition that because we are dealing with technology, especially technology moves very fast. And so the technology that we might have, or is available, let's say last year or the year before, could make significant advancements, let's say this year or next year. So we have to be nimble. So there was a recognition that we need to follow a very systematic approach. And so there was an adoption of this, what we call the system engineering V diagram. So this V diagram, basically you move from left, and then down this V, and then go back up this V, and then to the right. And my intention is not really to explain this V diagram, but just to show you a couple of things. If you have already developed an architecture, so you can start your project planning at this level, create what's called a management plan, and then develop a concept of operations. How does the system that you're trying to build look and feel from the, for the end user? Before you build the system, what's the expectations? And then developing, system requirements at a high level, and then looking at, so system requirements are the key functions and that you intend the system to do, and then you go from to the design side, and then the software development, and so on and so forth. This is kind of the same diagram, but so this is basically shows the steps of how to use the system engineering diagram. Again, there is quite a bit of information at the USA National ITS Framework website I showed. So you start again, if you don't have an architecture, you can still start at the concept level, then develop a concept of operations, or what we call a ConOps, and then you develop the functional requirements, then the high-level design, detailed design, and then the system software development. With that, I'm going to stop because of the time, and I will open it, for question and answer. And I'm going to stop sharing my screen.
Thank you so much, Mr. CHATILA, for the presentation. I haven't said in the intro, but I worked as a systems engineer for 7 years in defense and aerospace industry when I first graduated. So it's really exciting to see the V diagram and the systematic approach in the US framework for ITS systems. So it's really much interusable in between the defense industry, which is already using these V diagram and systematic approach in the ITS field. So it was an exciting topic to see that for me.
One thing to note, I forgot to mention, like here in the US, for the cities and the states to receive federal funding, they have to comply with these system engineering requirements. Because again, the government is trying to emphasize consistency and implementation of ITS projects across the entire country.
Thank you so much for sharing. So let's continue with Mr. SAADANI. He is going to share us a presentation about next generation data collection systems. So Mr. SAADANI, it's on you.
Okay. Okay, I'm Mohamed El SAADANI. I'm the president of Neovision Turkey and Neovision USA. Briefly, I work with a very talented team from Istanbul Technical University from 2019 till now to plan and invent and produce a system for artificial intelligence for traffic management data collection. And successfully, we have this system tested in New York City environment for over a year and a half. And I can present the system quickly because of the time limitation. So I'll go through this quickly because of the time limitation, but our system is a next generation web-based real-time automated machine vision, mobility counting, and traffic analytics for uninterrupted flow facilities. and it's being tested with accuracy over 95% during nighttime, daytime, and all adverse weather conditions. And it's not a data collection system. It's a comprehensive package of traffic engineering. It means it's a real-time data collection, data reduction, analysis, and also it provides data transmitted to traffic analysis softwares and simulation softwares. We produce like two types of system. They are the next generation, real time, and here we're going to focus on the systems that we are currently testing with New York City successfully, and they are for intersection and parkway. Also, they are AC, and also we have our short duration AC/DC, which are good for AC/DC and solar. You can see both of them in the screen. The permanent system components as a hardware, and the most important components are the camera, which is for intersection is Axis P3807 network camera. It's very good camera, it has 4 lens, and our edge computer, which is top of the line, and it's made in Taiwan. This is like the components of hardware for short duration, which is also the same camera and a processor that is designed and planned and produced in Turkey. And it shows the solar and DC type of power. As a software, it has the 3 important. It is good for traffic operation monitoring. It is good for multimodal data collection, and it's good for providing traffic analytics. Just a good group of measure effectiveness. And this is for, and it's good for, as we said, it's good for the real-time traffic system management data, and it's good for, at the same time, it's good for data for planning and design for engineers to use. And it's also data for, and it's good for uninterrupted flow facilities, and it produces a full package of highway capacity manual, and it's good for by lane, for average speed, vehicle classification, and measure of effectiveness, highway capacity manual results. It's good for the 4 components of the highway, which is basic segment, on-ramp, off-ramp, and weaving area. And here this diagram shows how it is good for the traffic management. It provides sensors for data collection, data reduction. It provides visualization for monitoring. It provides, it can provide data for the operation detection to operate the traffic controller and cabinets. And it's the future of the traffic management system. Here it shows like intersection dashboards for traffic management, traffic operation, centers operation for both intersection and freeway. This shows like transmitted data to VISM, to Synchro and VISM. So you can produce simulation, and simulation could be for existing condition, and then you can utilize this simulation for future condition with recommended improvements. this shows like the location of our current deployment with New York City DOT. It's 2 intersection and 2 location of highways in New York City. This shows like our collaboration with New York City DOT inside the Traffic Management Center, and shows here Dr. Talas and His Excellency Ben Ali Yildirim. During 2 months ago, he was in a visit to New York City DOT to collaborate and to see the demonstration of our system there. And this is some location for current installation within Turkey right now. And also, our system supports the future of the connected autonomous vehicle. And my 5 minutes are completed, so let me go for let Dr. Talas present his presentation.
Thank you so much, Mr. SAADANI. We have a few questions from attendees, but I will ask them right after Mr. Talas's presentation. So, Dr. Talas, can you briefly introduce yourself and keep up with the presentation?
Sure. Mohamad TALAS, I'm Director of System Engineering, ITS Deployment in New York City Department of Transportation. I have been in this project management of ITS deployment for a couple of decades in the city. And today's presentation is going to be more of our experience here in New York. So it's from a deployer perspective, actually. Just a little highlight about New York City. New York City has a very large infrastructure. We have 13,500 signalized intersection, very high dense infrastructure, almost 400,000 street lighting, 26,000 miles of travel lane. 25% of the real estate is roadway in New York City in the 5 boroughs. So we share the big cities' challenges of congestion, of growth in demand, of limited existing capacity. Supply system is confined, and in addition to the confined access points. So New York City has multiple islands, Brooklyn and Queens and Manhattan as an island, also Staten Island, the 4th borough, and the Bronx is semi. So all those environmental, geographical, and travel demand constraints adds and shapes the characteristics of traffic in New York City. And along with that is our responsibility in how to manage, develop, upgrade, and modernize such a large-scale system. So with that, I want somebody to share my presentation. Is it on? I can't hear you, Mr. SAADANI.
Yeah, give me the access. I'll share for you your presentation. I have it. If they can give me the access to share for you. Share it. Yeah, give me the access. I'll share it for Mr. Talas, please.
I think Mr. Errol made it right for you.
Okay,
I cannot give
I am
you the access.
disabled here.
Yeah, it's now on.
Okay, all right, fine. So we can go to the next slide here. So I gave you the introduction. Next slide, please. So the outline of presentation, we're going to talk a little bit about the current condition and challenges of transportation, the trend and the future demand, the potential and solutions, user need and planning, present progress, and the step forward to the future. Next slide, please. So the current condition and the challenges, we talked about the urban congestion, and this seems like is, across the world, in all big city, we have that symptoms, and it's not going away, regardless with COVID and without COVID. So yes, we had some impact during COVID time, but things are went back to normal everywhere. So the demand is continuing and the growth is continuing, and we have limited space in big cities. And that's what the next bullet point is: limited spatial network. Increase of demand of other mode and bike buses. We see that now the trend is, it existed basically in Europe, that multimodal aspect, and more of a share on the roadway for the biker and the pedestrian. And this is going even further. Now it's a trend also in the US cities as well. And this has to be, or being right now, accommodated at the intersection level and the block level as well, for the dedicated bus lane and for the dedicated bike lane, and control operation at the intersection. Rehab of the roadway infrastructure. This is also critical for our cities. A lot of cities was developed basically during the shipping mode that was the dominance in the world. So cities located on rivers and ports, and the infrastructure was built somewhat at that point, based on the carriage transportations of horses and stuff like that. Some of it developed, was modernized over time with the automobile industry, but some cities infrastructure continue to be old as far as the planning, the geography, the widths of those streets. Sometimes some infrastructure that need to be also rehabbed. So this is also the constraint. So as we deal really with rehabbing and modernizing, and maybe little bit expanding the capacity of the roadway, this become a very big challenge to accelerate that modernization across the cities, and to basically find the funding basically to do that, and do it very efficiently with the help of the ITS technology. The other point is the EV and the AV infrastructure need. Electric vehicle is also as a trend, and it's moving along, and we have now some streamline of production and ownership of electric vehicle. Autonomous is little bit, and it's moving along. But the electric vehicle has its definitely value for the consumers. So people are buying this, they taking advantage of also, some help from the government and compensation at the end of that purchase, or at the beginning of the purchase of owning electric vehicles, saving on the fueling, dependency on organic material and oil. But that comes with the challenge of charging stations. So how do we do it? In the suburban area, we have more room to build charging stations along with gas stations, with other 24-hour station off the highway, on the highway. There is multiple technology in the street, on the street in big cities. It's a challenge, and we have to work on that challenge and provide a model for a block that would be EV friendly. The AV also, it's autonomous vehicle movement and performance require a very unique and very much of accurate information and guidance in the roadways, in the block, signage, marking, geometry, temporary changes of regulations. Those are all issues for autonomous vehicles. So we have to keep in mind that as we are more into autonomous vehicle deployment and accommodation, we have to have the block, the right infrastructure for that autonomous vehicle. Would we consider first to do it on a certain travel lane like HOV lanes or confined access points, and later on go to the other travel lanes as well? So that is something that we have to consider. Safety enhancement demand. You know, in the city, in the United States, we still have a fatality of over 30,000 fatalities throughout United States, resulting from traffic accidents. This is continuing despite the improvement of vehicular safety and all the improvement of associated with the vehicle safety and the learning. But that would lead us to do more work, and more work on that area is going to lead us to connected vehicle and autonomous vehicle. Connected vehicle definitely will address a large significance of the safety issues that causes crashes and prevent that from happening to a certain point. An autonomous vehicle, when the computer and artificial intelligence reach a point that is going to be safer than the human basically responses, this is where we can start adapting autonomous vehicle on part-time basis at class 3 level or further to improve the safety when necessary, like the automatic braking application. When a vehicle, autonomous vehicle, will detect an object that will, you know, in the front, in the downstream of its movement, and respond to it by braking. So that's one of the application. Budget constraint. Definitely all those projects on roadway, it costs a lot of money, so we have to look for resources. One, for resources basically of funding those transportation projects. Second, to keep an eye on sustainability and cost effectiveness of our deployment. So in the V diagram, we saw that connection basically from one point, the beginning, the planning process, to the final testing. But I also like to add that how to maintain and operate, how to picture maintenance and operation later on, as far as cost and feasibility, is very important to be pictured ahead of time in the planning process as well. So that's something that we keep in mind. Supply system efficiency. Yeah, we have an existing supply system. As much as we have the tools to detect the behavior of the supply system, we will be able to make that improvement on how to operate that supply system as transportation network. Free demand increase. That's also very interesting, given that you have more dependency on online, basically transportation, retail, and wholesale, whatever it is, and that generate and home-based work as well. So we have increase in that area, and that means increase of freight also as well. This things has to be dealt with as we see it. Network security. Also, this is also a huge challenge in our area as a public agency or as in the private as well. We see it and we see those incidents all the time. So the work on how to ensure our deployment, our devices, or whatever infrastructure we have, regardless public or private, and making sure that is not hackable, it is secure, also from any interference is very critical, and it's advancing at that time. We have now standards to introduce TLS on all transportation devices, which is certification authentication system. Next, please. Next slide. A trend in future demand. The trend is based on the current, basically, and we talk about it. Traffic demand, multimodal, EV charging, AV and CV demand, smart city initiatives. Okay, we talk a lot about smart cities. Okay, and the smart city, basically, as we picture it, is more of a right now futuristics. I like to take it. I think we missed one slide by mistake. I think I like to make it more simple. I like a step forward, so we can make a smart grid system. We can make smart block, smart intersection, smart street light, and smart zone. Then we can end up with a smart city. This is very much feasible if we start that way, rather under the perspective, the general perspective of having at the end smart city. So this is happening, and that is the trend, and it's doable as we see a lot of deployment of the internet everywhere, and the wireless communication. We'll see example later on. And home-based work, we talked about it. That's an increase, and the opportunity of more funding to support those deployment and those enhancement. Next slide, please. Potentials. Currently, we have a lot of area, a lot of development. This slide is based on my experience. I would like to start first with the highway traffic management potentials. There is more tools now that we can monitor every inch of the highway by measuring the travel time, basically, and having also video surveillance as well. Second level is local street signalized intersection operation enhancement as adaptive control, and that is dependent completely on what traffic control we have at that intersection or at central location, and what detectors we have that provide us with the performance and the data that represent the performance in real time at that intersections. Some high level of accurate information that we can simulate, we can change it, and we can test it and deploy it and change that intersection operation. And this not only an intersection in the middle of nowhere. This can be a segment of intersection, and it can be a grid zone also. And for the intersection, for the link with number of intersection, and for the whole zone, there is prescription, and there is a treatment that we can do with adaptive control, with active traffic management. Street light operation efficiency, that is an issue of how much we spend. As I mentioned, we have almost 400,000 street lighting. So to operate this from central point, if they are connected as a smart city initiative, that will be a huge efficiency enhancement on spending on or maintenance. We talked about the block flow improvement for all modes, the safety improvement, detecting near misses. Safety improvement now, as we basically looking to deploy sensors to detect the behavior of vehicle, bikers, and pedestrian. We can detect as well near misses of accidents from those tools as video detection technology. And with those, we can basically classify that behavior and that near misses and work on a solution, to avoid those near misses before an accident that happened. And we can very easily go from one intersection to another intersection for a long period of detection time to address, those symptoms that are happening and detect it and work on a solution. Fleet route efficiency enhancement. This is also it's a potential, and I can see over here the AVL and the connected fleet would be a solution to basically to have a compliance with the truck routes, and also providing the operation comparable with the demand of that fleet activity. Highway and local street corridor operation. This is a very critical issue at exit and entrance ramps and service roads, how they interchange, how they basically interface as far as the travel activity, and how we balance the demand and control it from local street, from service road on highway, and when we can limit the discharge or the egress to the highway based on the performance, and keep the system flowing within a reasonable expectation. Weather changes and mobility impact detection and incident management enhances. This is something that happen. It doesn't happen as more of a recurring event. It will happen as basically non-recurring, but when it happens, it causes a big disaster on traffic. So something with the detection technology that we have, we can detect those, forecast the implication on mobility, and provide a solution, including advising the public ahead of time of the expectation ahead as they are planning to travel or in their way to travel. We talked about scalability of funding, so we can go to the next slide. Solution. Thoughts here, my thought of solution: optimize multimodal and demand management. So we have to know where we are with the current multimodal demand on the streets, includes vehicle, bikers, buses, pedestrian, and we optimize basically the supply system operation and layout to handle that, and also optimize the intersection control accordingly. The second issue, the ITS edge computing deployment to collect data. This has been advanced a lot, okay, and now it's very much doable. it can be in a small device that is added to any control cabinet at the signalized intersection and start collecting data with a very large size of memory. And at certain point also transform that data to a central point. This can exist anywhere at the intersection or in the middle of the block. ITS deployment to enhance operation and control. Basically, this means intersection control, upgrade, and traffic management, traffic surveillance. That's all exists, and it's improving. Example, today in New York City, as we have 13,500 signalized intersection, they are all controlled online from the traffic management center using wireless service provider solution. And all those intersection has Wi-Fi and Bluetooth receiver in the modem. So at any time, we can select a link, any link, point A and point B, and see the travel time between these two locations, or add more, integrated devices to that network. Asset management is very critical. As we are deploying technology, if we compare ourselves here from 30 years ago, we had only one intersection, one traffic controller to worry about, and probably a street light. Now things are expanding. Now the controller has multiple devices in it. The an auxiliary device is connected to the modem and others, and the block has more devices, the highway have more devices. So in order to basically have a good maintenance system and good operation, we have to have a very good asset management system. And that's a core basically for any smart city program. Design model smart block and grid system. This is very much feasible, as we said. If we don't want to jump directly to the smart city, large initiative, we need to start somewhere. We need to create a model and build on it. The IoT devices is now is very much doable. Everything is wireless. Everything can be integrated. EV charging solution is already there. It's a matter of deployment. AV compatible right now. Roadways are crawling, but it is within hand as well. Next slide, please. Next slide. This is just an example of what we have, our network in New York City. We have AT&T service provider covering all those 13,500 intersections. The project, what's interesting here, and to keep in mind, if you have an IP controller that can be interfaced with Ethernet at the intersection, you can add that wireless modem and you can bring that intersection online from the traffic management center. So the whole conversion here, it took us 9 months only during COVID time, during 2020. And we took advantage with the light traffic. So our contractor was going from one intersection to another without issue. So it was planned before for 1.5 years to convert to service provider from a city-owned wireless system. And it was done very fast. So that's an example, regardless of how large is the system, we can do the IoT of things very quickly, with wireless technology. Next, please. Cooperative driving uses. This is dependent on the IoT of things also of all the roadway users and the infrastructure. So everybody is talking to everybody. The bicycle, the pedestrian, the vehicle, the infrastructure also. So you enter a point, everybody is sensed at your hand with your smartphone. And with the proper algorithm and analytic, you can get the awareness to cross the street without the threat of a vehicle, heading into that crosswalk, while the driver of that vehicle also have your detection in his screen and in his audio alert. So that is what cooperative driving, and also it adds on to the interface to the other fixed devices, the cameras and the other sensors that is available to that in-vehicle device. So you see here example, basically pedestrian, a school bus, the students are connected, the bus driver is connected, the vehicle ahead is connected, the signal is connected to that in-vehicle device. So you have the more safety operation. So everybody sense who's adjacent to his vehicle or to himself standing anywhere on the roadway. The work zone is another example, because you have workers and you have construction vehicle and you have vehicle entering the work zone. So vehicle entering the work zone, they have those information. They have they are sensing the pedestrian, and they are sensing the vehicle. And we are not talking here about the driver cannot see, or the normal condition was the driver taking the precaution to avoid any conflict with the construction vehicle or the construction worker. But we are saying here, if you have enough sight of the driver approaching a work zone, those devices, the in-vehicle device, will provide awareness, so it avoid incidents as it happened, and we hear of it nowadays. Next slide, please. Smart grid system, we talked about it. Okay, we have opportunity here with the smart grid system to improve safety, as we can detect the movement, analyze near misses and avoid near misses. We can enhance the signalized intersection operation by those data that we are getting in real time and changing setting accordingly. We can improve travel efficiency and flow of all modes, because now the detection technology can provide us with all those multi-mode activity. We can enhance the performance of the highway and the local street corridor, as we spoke. Incident management improvement is potential for major weather changes. We spoke about one large incident that is not out of the forecast capability. The weather forecast capability can have a big impact on mobility, specifically if you have issues during rush hours and stuff like that. It multiply even more. And specifically also, if you have a limited access point, the traffic has to go to those access point, bridge and tunnels, and you have issues. Okay, so the weather impact and incident impact, major incident impact, is very critical. But to project that impact, to forecast that impact and its implication, okay, can only happen if you have proper detection technology, real-time data, and a good algorithm that provide reasonable expectation of what's happening in that zone, and advising the public and manage the incident accordingly. Last point here, we have support of planning and studies and operation. As we have more data being collected, we can plan better for an intersection, for a block, for a zone, or for a whole city. Next slide, please. Roadway user detection, we talked about it here. It's gonna get very interesting as we are into this technology deployment to detect those near misses, to get more information, and it's very encouraging to see that we have above 95% accuracy nowadays in the data collection. Next, please. Connected street light also, it's a simple example here of the IoT of things. Very small SIM card based device can be added with interface to the photo cell, and we can basically control the timing, control the efficiency and the demand accordingly of a street light. And it counts really very big when you have a very large system, a very large infrastructure. Next, please. I think we are, last thing is an example of security issues. New York City DOT deployed connected vehicle project on 3,000 city vehicle in the last few years and completed that network. But during of our work, we have to be concerned about the security of the vehicle, the security of the intersection control, the security of the roadside units, and all the devices. So as you and the pedestrian with all the vehicle, interface between pedestrian and vehicle. So this represents approximately 21 links here that we needed to protect. So we worked with network security with AT&T, as we are using that as the main medium back to the TMC. That is on its own, but we also have encryption level. We have hardware safety model to protect the hardware itself of each device. And we have also added TLS layer at all those few thousand devices to make sure there is certification upgrade of operation on weekly basis and the certification change. And there is a system, okay, safety, security, credential management system that manage all that security. So that's also an example. It was one of a kind for connected for mobile application that we did, and we experienced the challenges as we have been testing that later on. But that's something that is going to we all together build on as we go into the future. Next, please. I think I'm going to basically, since we talked about most of those issues, we'll skip this slide to the end. Step forward, I just want to highlight here, it's very important to do what we are doing today, okay, share our experience, education, outreach, knowledge, and awareness as much as we can. We should have strategic plan and a vision, a clear vision, always. Model deployment and testing, that's a road for a general upgrade. Standardization of product, as Mr. CHATILA mentioned. Cost-effective, scalable, and sustainable deployment outlook. That is also critical because technology is very nice, very good, okay, but nobody can afford, owning a smartphone every couple of years because, there is a new version. The government would like to see this deployment sustainable for the next 10 years anyway, before we modernize next time. Public and politics buying in, this is very critical, okay, because this comes with, expense. Public and private partnership is also critical, as everybody knows. I think this is my conclusion. And with that, I believe this is the end. And if we want to have some time for question for everyone, please do so. Thank you very much for listening.
Thank you very much, Dr. Talas, for the insightful presentation about the critical issues for the future of the cities and how New York City approaches these problems. It was so informative for us. So right now we have a few questions from our attendees. I would like to ask it shortly. We are running out of time. We are already past 5 minutes, but let's quickly talk a few minutes on those. So one of our attendees asked Mr. Hicham CHATILA, what are the main traffic problems in Istanbul and Turkey that needs to be solved urgently? Can you share some ideas for our attendees?
I just actually responded. I typed a few responses. I saw some of the questions. I think for this particular question, what I suggest is the caller to contact Mr. SAADANI, because again, we are talking about two main areas here: the urban condition, where we have a lot of traffic signals stop and go inside the city, and then what we call the uninterrupted flow, which is the expressway and freeway type of system, and each one has specific requirements. I highly recommend the person who asked this question to contact Mr. SAADANI, because I think he has a wealth of information that Mr. SAADANI can provide.
Yeah, for me, I really had the opportunity to work with SBAC for a while during my stay in Istanbul since early 2019 till now, and I was working with the very talented group of traffic engineers in Istanbul area, and I believe I wrote my thoughts about what is what I can see, what is good, and what is the deficiencies. I think the deficiencies are very minor, is not, but they are very important issues. They are, if we can figure out how we can solve these small issues, I think everything will be great in major urban areas in Istanbul, and it's related really to mostly it's related to pieces of the hardware for the traffic control of intersection, which leads to really some problem with the configuration, lane configuration of intersection, and it goes to the circulation, and it creates congestion. So basically, it's the cabinet controller. I think the major urban areas in major cities in Turkey needs to think about upgrading and updating their the brain of intersection, the cabinet and controller, also detection, and some training for the very good engineers. I did work with them. I did talk with them. They're very good engineers and good ITs and good management. And I said it goes from the brain of the intersection to the configuration to the of an intersection. It goes to the circulation on CBD areas. It goes to the production is congestion can be avoided, and that's my main concern. There is other issues, but this is the main issue. That's my answer.
Thank you for the answer, Mr. SAADANI. I think these are not only the issues for Istanbul. It's an issue for mega cities, and UN says by 2050 there will be 43 mega cities in the world because of the increase in population. So all these issues in Istanbul are going to replicate in a lot more cities in the future, and it's very important for us to implement these solutions and work on the concepts in these mega cities, I guess. So there is also another question for Dr. Talas. Mustafa asked, what kind of sensors do you use in your city for traffic management data?
We have been using different technologies since probably 30 years. In the beginning, we used loops. Then we have microwave sensors. Then we have some video detection in the past. And we have for travel time sensor, we uses easy pass transponders on highway, on also local street at a critical point. But now, given the idea that we have Wi-Fi at every intersection, we are using the Wi-Fi to do the travel time. Most importantly, now we are embarking on a large procurement of video analytic. As we conclude, the video detection technology has a major advantage in our environment. It provides us with the accurate data that we need at the intersection. It provides us with the forward and backward, basically looking at the approach of the intersection. And it is one point of failure, rather than multiple point of failure, because it's connected directly to the intersection controller. So that's those are critical points that we have in mind, and we're moving forward in that basically in that direction. We have some microwave sensors for speed detections, and we have the video analytic for intersection data, and the Wi-Fi for travel time.
Thank you for the answer, Dr. Talas. I also have a short question for you. As I am the founder of a micromobility company, it's about micromobility for sure. So we think that micromobility is a widely accessible solution for urban congestion, lowering carbon emissions and solving first last mile problem in the cities. What is your approach to micromobility, including e-scooters, shared bikes and shared e-bikes? Do you see this as another future challenge for the cities?
I don't see that as a challenge rather than it's a solution. But this has to be optimized to the proper environment. For example, if we look at scooters and how to operate scooter. Scooters needs dedicated bike lane, let's call it, if they are sharing the bike lane. If you have a certain area with a fairly large sidewalk and much less pedestrian activity. So you have that sidewalk shared. I'm not sure about the legality now of the scooter, going with the pedestrian on sidewalk. But that environment, you could see that is very much doable for scooter. Other environment where you have high density of pedestrian activity, that it will be basically an impediment of scooter usage, unless you have dedicated lane for scooter and biker. Biker solution is going very well. Why? Because there is bike lane is being constructed in most cities, in most major segments. That is, again, it's a nice solution. The electric bike, it's an add-on advantage also, because definitely it makes using the biker more friendlier, for different ages, different capability as well, human capability. So that's excellent. I believe micro mobility can work, but we need also micro geo deployment comparable to that micro mobility, so that it will be perfect then. That's my thought.
Thank you. It's like one of the biggest challenges we have in Turkey, because we don't have a developed infrastructure for bike lanes. However, we hope that this transformation is going to drive the public and the government faster to act on investing on bike lanes in the close future. That's what we support currently in Turkey.
That will be definitely interesting. New York City, some 15 years ago, didn't have much of bike lane. We had them more on major access point like bridges. But now I believe there is probably 10,000 or more. I'm not sure exactly. Bike lane all around. There is very nice and successful bike lane utilized very nicely. And there is some that are could be less operational, but I can see the trend is moving in that direction, and there is more attractiveness, more induced demand to those bike lanes that are being constructed. Every environment has its challenges. I'm not sure about Istanbul and its elevation, and where it can be, used. But again, when we start anything, we start where we need it most, where it can work most, okay? And we invest, and we take this as a template and a model for the rest of the implementation. So it's always good to start at certain point, at the proper point.
Thank you, Dr. Talas, for the answer. So we are 15 minutes past the event, but thank you all our speakers for their great contribution today on our subject. We hope to see everyone in the upcoming webinar series from ITS Turkey. And also thank you to all the attendees spending time to watch us and view our speakers. So wish you all a great day. I guess this is the end of our webinar today, and hope to see you again. Goodbye.
Pleasure.
Thank you.
Take care, everyone.
Thank you.
Thank you for the opportunity.
Thank you.